Hello, everyone. Nice to meet you all. Happy to be here for this session. My name is Charles, and I'm the CEO at Letria. Letria is a French company that we started in 2019. We are now a team of 20 people, and basically we help organizations add transparency, auditability into their Gen AI apps. On a daily basis, we are mostly working on RAG applications, question and answering on complex documents. And we help organizations that come to us with disappointment towards their RAG, their existing RAG setup, and they are looking for much more improvement when it comes to parsing the documents, when it comes to having better answers, right? So our daily job is to assess the feasibility, assess the complexity of their use cases, and help them move the ladder of accuracy rate and go up to a threshold that create trust with the business experts. I'm going to talk about finance today because that's an area where we are very strong, but we also work with different organizations in various verticals. Could be healthcare, could be life science, could be insurance or manufacturing, for example. All those verticals where you are dealing with very complex documents, you need to query those in very complex terms. And this is where knowledge graphs can become very handy and can add a lot of new context to this. All right. So let me start with the typical life of financial analysts. And we've talked to hundreds of these people. And so what came from those discussions is that they are dealing with very messy documents. You can see examples from our clients. This client is called Euronext. It's the European stock market. And so they bring in their database very complex multimodal documents. Could be slides from PowerPoints, could be PDFs with very complex tables. Also going from semi-structured with tables and a kind of pattern to unstructured data, pure text. And so we need to manage the different elements that come into the input of the database. So there's a first challenge here when it comes to assessing those documents and parsing those. The second element is that they are fetching information into these files. They are looking for a lot of very precise point of information. And so they spend roughly 15 to 20 hours a week looking on this. So there's a huge pain here. We're not talking about, something that could be nice to have. We're talking about something that could definitely change their everyday life. If they can be able to query in a natural language, very complex documents with very complex questions, then they can get directly to the right point of information and it can help them solve issues or take decisions. So the type of questions that we've been working on top could be numeral reasoning, so involving a lot of different dates, involving timelines, involving growth forecast, for example, with temporal reasoning. And so you want to merge percentage with dates and you want to see how it evolves, for example. Also, we are working on top of tables, so we need to be able to extract the specific point of information from the table and also combine it with different criteria. So it gives multiple constraints, and that's why it's super fun, because we are not talking about pure search, we are talking about something that goes far beyond. And so most of the time they come to us and they come with a problem, which is their vanilla RAG, their baseline RAG, which is purely vector-based. Roughly 100% of the time, they come with a first setup of RAG and they tell us, okay, it's doing the trick for some of my use cases. Let's say if I want to automate customer support and I have very simple documents with very simple queries, then it's doing the trick, and there you don't want to touch it. If it's working, then leave it. However, they have identified a lot of use cases that are very strategical for them, where it's not working, and the business experts have a lot of issues with that. First element is those hallucinations that are clearly a huge hurdle because basically you get wrong answers and you don't have the means to understand why it's wrong, and you don't have the means to audit the context, to audit why the LLM has proved to go to the wrong direction. And it's stemming and it's adding a lot of mistrust, which is for us the key value here. We're not talking about accuracy rates. You can set up a threshold at 80%, 90%, 95% accuracy rate. It's up to you. But behind this, the most important is the trust that you create from the machine to the business expert. If you're talking about with financial analysts, you really want to have them in the loop and you really want to create the bond with them. So if there's a hallucination, definitely it's a hurdle. But if you can manage to point out the reason, the roots of this, and also solve it, then you are recreating, maintaining the trust bond. So that's why those two elements are intertwined. Let's talk about those benchmarks. When we have clients coming, inbound partners coming, we are, spending a lot of time to evaluate the quality of their existing RAG. And so in this specific benchmark, we have developed a series of questions that are multiple types, numeral reasoning, temporal reasoning, multiple constraints. And we have found out the correct answers, the correct chunks of information, the correct documents where these answers are based from. And we have then benchmarked and we have used a state-of-the-art vector RAG pipeline that is called Verba by a company called Weaviate, which is a leader in the vector store space. And we have used their baseline configuration. And what you can see is that if you are combining the acceptable and the correct answer, so acceptable means it could be incomplete, but the business experts deem it okay and deem it that it helps their everyday. If you combine those two, then you have for the first setup 53% acceptance rate, and for the second setup 60% acceptance rate. So this one is based on GPT-4o. So you can see that in many, many use cases, flipping the coin and having only 6 answers out of 10 that are reliable is not something that is just compatible with our everyday. It's just creating too much mistrust. What we want to do is definitely work on these figures and make sure that we improve from their baseline existing RAG. So that's what we do at Letria. We have developed a graph RAG solution that is really good at parsing information, really good at retrieving context. And then this solution can be a real improvement in your everyday. If you look at the figures here, we are reaching far more acceptance and correct answer. We have multiple configuration here. We have a 3-chunk and a 6-chunk configuration. So let's look at the right option. As you can see, we are performing more than 96% of acceptable and correct answers. So we are, reaching the 100% and getting close to this. And definitely what we want to do is on this baseline, then fine-tune it for the specific use of the client. So the 96% here is the baseline graph RAG rate. And then we can set up the parameters, fine-tune the embedders. We can tune so many different tricks that can go from the 96 to the 98, 99%, and then, of course, reaching this idealistic 100% plateau. So basically, here, it's just not about the figures, it's about the trust that it's stemming from this acceptance rate. And what we want to do is show the improvement in the pilot phase and then create the best soil for the production phase. So roughly speaking, whether it's on finance, it's on healthcare, it's on manufacturing, we have at least 35% in accuracy improvements, accuracy increase switching from a baseline vector RAG to a graph RAG. I'm going to go into the details of what the graph RAG is, because it's fairly important to understand how the knowledge graphs, and especially the Neo4j by default knowledge graph that we use into our solution, is adding a lot of context. The first part is the document parsing that could be solved also through the knowledge graph, and the second part is the retriever. I'm going to go into the parsing. As you can see, the tables are very, very important here. They are centralizing a lot of point of information, and you really want to respect these tables because a lot of questions are leveraging this information. And in an existing pure vector store, it's really hard actually to export this information, structure it, store it, and make it queryable. What we want to do is we want to identify those points of information and we want to turn them into a graph. And that's where knowledge graphs could be, of course, very handy, because you can understand the ontology of the table. You can understand all the relationship between the cells of the table. You can understand all the concepts, and there are pre-existing ontologies that are ruling some table structure that are very, very common in the graph space and also in the finance space. So you want to leverage those, and you want to use existing formats that are very, very interesting. For example, I'm often working on top of XBRL files that are basically all the files that you can get from the US regulators, and especially the EDGAR database. You can export these files and you can turn all those tables into graphs. And definitely those graphs are going to have very rich information coming from the table, and you can be able to store this information in a way that you can query it very easily. So this is basically the output that we get from a table and a part of a table. So imagine you go from a format that is not easy to read for machine to something that is pretty easy to read for machine and pretty easy to query as well. That's one of the first levels that you can action with knowledge graphs. And that is definitely going to have a lot of impact in your financial RAG application. I'm going to talk also about the context, because of course, if you're not retrieving the right information, then you're not feeding the right information to your LLM, then of course the answer is as an output would be misleading. So the very core of the graph RAG is the hybridation of a vector store and a graph database. So we are not purely working on knowledge graph. We are also, of course, leveraging the high computing of the vector store and the embedders, the high velocity they have, but also we are adding a lot of domain expertise through the ontologies that we build with our users, that we automatically build into our solution. So you can come with an ontology, but you can come also without the ontology, and we are automatically building this ontology with our tool. So you just have to validate the assumption of the machine, and then you can produce automatically your graph. And we're going to merge those two in the context of the machine. And ultimately, what we are aiming toward is the reliability of the answer. So I suggest we just have a look and we just go to our platform. So you should see my screen right now, and I'm going to, benchmark directly a vector RAG configuration and a graph RAG configuration. Here, we're going to stick to the baseline vector RAG from Weaviate, which is called Verba, and we're going to stick to our graph RAG by Letria, by default configuration. So there's no fine-tuning, no setup on each side. Here you can see that we have emulated these questions. And for example, there's a first question, which is a multi-hop question type. And basically the question is, what year did Angie Jassy join Amazon? So he's the CEO of Amazon. What's interesting is that it's the same database. So as you can see, I'm going to have the same documents as the input. I'm going to have the shareholder letters, 2021, 2022, and 2023. But here you can see fairly different answers. The first one from the vector rag is that, so it's saying it doesn't know, so I assume it's half correct, because in a way it's not misleading. It's saying that it's unable to retrieve the information and provide an answer. However, what's interesting is with the same data, we are capable of fetching the right information and of course giving you the right answer in a natural language. Here, what's interesting is that you can investigate the context of the graph rag. You can investigate how hybrid this is. We will base our answer from the chunks that we retrieve with a similarity score, but also from the graph. So I can audit and I can understand why we came up with this answer. So I can go into the relation, I can go into the notes, and of course I can check why this part of the graph has been retrieved and how it's helping to get to this answer. So here you can see that you can also, of course, navigate into the JSON file. In that specific area, I presume that we are more familiar with this visual aspect. I mean, it's easier for a human to read it. But this is a first question where you can see that GraphRag can clearly make the difference. I'm going to go for another answer, another question, sorry, because this one is also pretty interesting as for the construction of the answer. What you can see is that here we are not able to retrieve the information, and thus we are not able to give the right answer. And here what I want to show is that with GraphRag, you can structure your answer fairly differently, and you can go up to something that creates more value to the end user. Okay, here, if I check on it, I have both the chunks that are retrieved and also the knowledge graph, the part of the knowledge graph that can help you dive into the information, the point of information that are checked from the documents. So that's it for this this test. So I'm gonna end up with a first methodology on how we can easily work with partners to build their GraphRag. So the first part is that we can accept documents in any format. Our parsing API can accept 15 different formats. Could be JSON, HTML, PDFs, very complex with different columns. Could be multimodal data with diagrams, for example. Could be PowerPoints. We have seen a lot, and especially in the financial space, it is very rich when it comes to documents and very unstructured. The second part is that we are going to build the ontology automatically. We've assessed that if you build your graph on top of an ontology, in the long run, it's going to be more consistent. In the long run, the retriever will be more robust. So that's definitely something that it's core to our methodology, but it's automatical. You don't have to manually edit this ontology, which is something that's a bit appalling first. Our first partners were a bit threatened by the ontology part, and it reminded of some traumas that they spent years building ontologies and maintaining those ontologies. Now we can, based on your documents, emulate a use case oriented ontology. And then we're going to turn it into the ingestion pipeline, and we're going to produce the hybrid database that is based on a Neo4j graph store and on a Quadrant vector store. And then you can directly talk to your graph in natural language. So that's basically how we work at Letria and how we can reach that level of accuracy and reliability for answers, which is definitely the main element that I want you to keep from this session. Is let's talk about figures, let's talk about accuracy rate, but in the end, What you want is to create a bond between a human expert and the machine, and you want to help them solve their everyday issues and help them save a lot of time weekly. I'm going to end up with a short description about the company Letria that we have co-founded. We are a team of 20 people here in Paris. We had a bit more than 6 million in funding, supported by tier 1 VC funds here in France and Europe. And yeah, working purely on graphs and how we can help graph, get the best of these Gen AI use cases and recreate what we've lost is the trust and the explainability with the machine. That's it for me today. I guess we still have 5 minutes if we have time to cover a few questions. I don't know, Martin, if that's part of the session today.